We still have a process to try to do it. Anyway, this process leads to this type of thing here. So let me ask you guys, we wrote this down last time. Can somebody tell me what is the beginning of trying to find? This work here. Oh, did I bring a pen? No. I got one of these. Let's see. Let's use you. I choose you. All right. Anybody know? What does this find in general for a function at A? What does that process find? Slope of the tangent line. I love it. And again, tangent line is if whatever force is keeping me on this track stops keeping me on the track, that would be the direction I would go if I was let go. So you can imagine somebody swinging something and letting go. It takes off along the tangent line. Right? And of course, gravity says, screw your tangent line, but I'm just talking about right when it leaves. Okay. So this is given x squared. Can you find the slope at x equals 3? Like, of course, algebra would freak out. They don't have a, what the hell? I don't know how to do that shit. But we're cool with this because we got this process. The process allows me to have 2 points forever, which is what the slope needs. It needs 2 points. But it shows me what it looks like it's approaching at that point, 3 in this case. So this would just answer the question, given x squared, what is the slope at x equals 3? This is the work I would do. y2 minus y1 minus, it's divided by x2 minus x1. You guys okay out there? So then, why is this easy? Yeah, it's easy to factor that bad boy, right? What's up with the bad boy shit, Jeff? You've been saying that a lot. Right? And then you can kill the problem, die problem. So then you get 6. I like it. So what? Tell me everything we know about this function at the input 3. What do we know about this function at the input of 3? What equals 6? The slope equals 6. I like it. This is not the, I really want, is this the limit of the function? No, hell no. This is not the function. That would be the limit of the function. This is the limit of the slopes between points of the function as they get closer, right? Okay, let me stop for a minute. So we have the idea of limit that exists by itself. Whatever function I put inside of it, it will discover what the limit of that function is. What is this function I put inside of it? The slope. So at x equals 3, the slope is 6. What's the more technical way to write the slope of f of x at 3? What? F, yeah. In fact, we'll say f prime of 3 is 6. So if I ever see this just sitting around, you know, like on the ground or something, the slope of the function at x equals 3 is 6. That's how to read that. Okay, I like it. Can you figure out the equation of the tangent line? There's one more thing you need to know. I know the slope. What else do I need to know to figure out the equation of the line? Yeah, that would be great. We don't know it. I do know the point 3, 9. Yes? The function goes through, if f of x is x squared, doesn't it go through the point 3, 9? And the slope is 6. So can't I do this beautiful little... And of course, you could also set up mx plus b and solve for b. Either way. I try to throw this one at you more often because later this semester, this is going to become kind of huge. And it's not going to look exactly like that, but We're going to build something based on this. So y minus the y value equals 6x minus the x value. 6x minus 18 plus 9. Shaba! Let me go one step further with this. Can you, Jeff? We're going to find out. Go to this thing. Okay.
Do you have kids?
No?
Okay, just wondering.
That was awesome. That was out of nowhere. Do I have kids?
Yeah.
Okay.
Of your own
I love you guys.
that are not animals.
I like mint chocolate ice cream. Mint chocolate chip. I don't know what other questions. My favorite color is blue or green, depending on the day. Now watch this. There's the function we're analyzing, correct? Right? If I plug in, oh shit, I love you guys. You guys are awesome. You guys are all like, we trust you, Jeff. All right. That was amazing. Old man with technology, you gotta remind me. All right, that's the function we're talking about, yes? X squared, there it is. If I plot in here, what do you get, 6x minus 9? Does that look like it does what it's supposed to do? Here's 3, 1, 2, 3. So it hits the parabola at 3 and it follows it right there. And of course, why does it kind of come away from it up here? Because the parabola, the slope of the parabola keeps increasing, right? Isn't the slope of the parabola increasing? As they get past this point, doesn't the slope of the parabola increase? But the tangent line, of course, it's a line. It's going to stay the same slope. Isn't that kind of cool? If you ever figure out the derivative, the slope of a function, you can actually just plot the function, plot the equation line, and make sure it does what it's supposed to do. Okay. Maybe. Maybe. All right. Now, last thing we got to talk about, and then we can open it up to review. This process, oh shit. What process, Jeff? I don't know. This process is not the one we use most of the time because, just to remind you guys, I tried to make a point of this earlier. Why was this one easy? Because the top could be factored very easily. What if I had an x to the 5th? X to the 5th minus 3x to the 4th plus 7x squared minus 2x plus 1. Is that easy to factor? Could you factor it if you had to? Yes, you could. Synthetic division, anybody?
No. What?
Synthetic division, is that okay for me to say?
No.
We'll cover synthetic division later. You don't need it right now. Don't freak out. My point is, do you want to do a x to the 5th factoring problem? No. So now I really want you to buy into the fact that generally this, Jeff, generally this is better. You could do it, Jeff. Because this doesn't, yes?
Is that an O or an H? Or an A, sorry.
No, it's a 0. Yeah.
It's a 0? Okay.
Yes, he says. All right, just remind you guys. I love you guys. I thought I had 0 down pretty good. I guess I don't. What was the idea behind this? Don't I want to know the slope at A? All right, so I have some function. I want to know the slope at A. Can't I go just a little bit away from A? H away from A? So then I have 2 points, and then what do? I let the other point get closer. How do I let A plus H get closer to A? I let H go to 0. Okay, let me stop for a minute. Yes?
You looked at that, and what makes you think you want to go to A?
All right, here we go. The problem that leads to this setup is, what is the slope at A for this function? So I want to know what the slope at A is.
But what's telling you to do that?
That would be what the problem says.
Oh, okay.
So this is the procedure I use if I want to know the slope of a function at a point.
Okay.
Okay. I like it. Now again, this was pretty easy, right? Because the function was easily factorable. How often does that work? How often does that happen? Not often. If I just pick a random function, you ain't going to be able to factor it. Hell no. So this is more generally accepted because there's no factoring involved in this process. Why is this one involved factoring? Because the bottom is x minus a. It's a binomial. I have to factor it. I have to actually factor it in. What do I have to do here? Evaluate the top and then cancel the h's. All right, so let's try one. What are you doing? There we go. Let's do a function. What do you got, Jeff? Yeah, let's do that one. That's going to be fun. X cubed minus 2 at a equal to 2. Sure. Everybody's like, did he take his meds this morning? No. So I want to know the slope. This is what the problem. I'm not really writing all the words you would see in your homework. It would say find the slope of f at a equals 2. Okay. So what I need is, so this is the official definition of derivative. The other limit works also, but it works less often. So that's why this is the one that's more standard. We always think of this when we think of derivative. So let's make it more specific for this problem. I need the limit as f of 2 plus h as Jeff. Let's try this again, buddy. As h goes to 0. So that's closer to what we're doing. Is that cool? Because I want at a equals 2. So I want to let this get really close to this. And then I want to figure out the limit's going to help me keep track of what that slope seems to be going towards. All right, let me stop for a minute.
You lost me.
Are you with me there?
Yes.
What's a?
2.
So all I did was replace a with 2.
Okay.
Okay. Okay. What is f of 2? Yes, right? 2 cubed minus 2 is 6. What is f of 2 plus h?
Oh, it's 6.
Come on, you guys are better than this.
It was 0.
Why is it 6?
I love you guys so much. Is h ever going to be 0? Nope. So can you plug a 0 in for h? No. Okay. F of 2 is 6. Why? Because when you plug a 2 in, what do you get? 2 cubed is 8 minus 2 is 6. What is f of 2 plus h? 2 plus h cubed. You got to do what the function tells you to do, right? What's the function tell you to do? Whatever the input is, I cube it. Are you happy that this is what you have to do? No. Do you have a choice? No, because that's what the function is. So I really want to bring this back to you guys. What I'm doing is, that's the definition of slope. This is kind of like closer to what I'm doing, right? Then I can focus on what the hell that is, and what the hell that is, and then I can throw that stuff back in here. So I'm kind of building what I need. Yes?
Why would the outside function be 2 as well? The second f of 2, that one be 6?
This is totally 6. We figured that out. We still need this.
Oh.
Okay.
I see.
So now, the trade-off between having a function that you don't want to factor because it would take synthetic division and a lot of time is that you have to do this. But that, of course, is just busy work. It's like, just grind it out instead of go insane trying to factor something. All right, let's see if we can handle this. Do you guys know? All right, let me see. Real quick. Does anyone know? A little side note. I'm really curious what your notes look like for this class. Does anyone know the shortcut to doing this?
Oh yeah.
And again, this is unnecessary, really. It's kind of unnecessary, but it's going to come back in a big way, so I might as well throw it to you right now.
X cubed plus 3x squared.
Yeah, where's that coming from?
Well, the x cubed. Oh, right, the triangle. Pascal's triangle.
Pascal's triangle. Has anybody ever seen this?
Yeah.
I love you guys. Holy shit. All right. And again, don't take that on. It's not your fault for not seeing this, because you don't know this to show yourself this. So don't worry. What's the sequence here? Put ones on the outside. 1 plus 1 is 2. Put ones on the outside. 1 plus 2 is 3. 2 plus 1 is 3. Ones on the outside. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Right? So it seems like a math person was bored waiting in the DMV and just kind of doodled shit. But this is Pascal's triangle, and it has an incredible amount of uses. Holy shit. The most immediate use. Real quick, let me get you guys to buy into this. This is quick, right? What's x plus 1 squared?
1, 2, 1.
X squared plus 2x plus 1. What are the coefficients? So what's x plus 1 cubed?
1, 3, 3, 1.
X cubed plus 3x squared plus 3x plus 1. And you can double check me if you want to. Now, the real trick behind this is, what would x plus 2 cubed be? And again, you don't have to do this. You could actually just write x plus 2 3 times. It's not that big of a deal, but good God, what if it was x plus 2 to the 6th? Right? So watch this. This is kind of cool. Let's see if you guys get this. So it's all this. Then it's 3 times one of these and 2 of those. I'm just going to keep going. Then it's 3 times, Jeff, what did you just do? You said 1, so of course you put a 1. 3 times, so it's all x's. You with me? All x's. So all x's. Then it's 2 x's and 1 2. 2 x's and 1 2. Then it's 2 2's and 1 x. And then it's 1. Why wasn't that happening up here? Well, it did. This was all x's. This is 1 1 and 2 x's. This is 1 1 and 2 1's and 1 x. So the 1 squared is 1. So it didn't really show up. Has anyone ever done this before? A little bit? Some of you guys are no? Okay. So again, this is so cool. Doesn't this start off with all of these? Yes? All 3 of those. Then it goes to 2 of these and 1 of those. Why did you put a 1 at the end, Jeff? Because you're crazy. Then it goes to, the last number's wrong. Then it goes to 2 of these and 1 of these. And then it should go to 3 of these and none of these. There you go, Jeff. So this will be x cubed plus 6x squared plus 12x plus 8. Yes? 1 3 3 1. So here's that 1. So the coefficients are 1 3 3 1. And what happens is, it's all the first dude times 1. Then it's 3 times 1 of these, 2 of these. 3 times 2 of these, 1 of these. Right? So you have all x's, no 2's. 2 x's, 1 2. 1 x, 2 2's. No x's, 3 2's. Okay. All right, I'm not going to spend a lot of time. So now we got, if I replace x with h, do you see how we did this? So I can put down here h cubed plus 6h squared plus 12h plus 8 minus 2. Now you could have just written 2 plus h, 2 plus h, 2 plus h, right? And then multiply. That's okay. All right. So right now, if you don't understand this, does that mean you're going to fail the class? No. Okay. I just want to show it to you right now because it's going to come back later and then we'll focus more time on it. Now, So the only thing we did was I showed you a shortcut for doing something like this. That's all it was. Now I know what to put here. I put all this stuff there, and I know what to put there. So what's this become? This becomes the limit as h goes to 0. Let me put all this stuff here. H cubed plus 6h squared, 12h plus 6, right? Minus 6. Do you see how the only thing that didn't have an h cancels? Right? So that, what does that mean I can do? So is everybody with me? All I did was put this where it goes, and I put this where it goes. So is everybody cool with those die? Yes, of course. And then I can cancel one h out of everybody. So what do I end up with here? I get limit h goes to 0. Well, let me, I don't have to write that anymore because I'm going to actually plug a 0 in. Go away. So this will be 0 cubed plus, no, Jeff, you're trying to do too much at once. Let's cancel an h, cancel an h, cancel an h, cancel an h. So it's 0 squared plus 6 times 0 plus 12. So of course I get 12. Okay, let me stop for a minute. So that's the beauty of it. It's a trade-off. You're going to have to deal with whatever power this is. The trade-off is that is a lot easier. It might take a while, but it's better than trying to factor some disgusting thing. That's the trade-off. What the hell does this mean? Do you remember what we're trying to do? What does that 12 mean?
That's the slope of the tangent line.
That's the slope of the tangent line to this function at
X equals 2, or A equals 2, yeah.
Okay. And of course, we already did this down here, but what point does this go through? Yeah, it goes through the point 2, 6. So now I know. Let me get my side note out of the way. Let's collect what I know. It goes through the point 2, 6. It's got the slope of 12. And then I can do my little thing there. Y minus the y piece equals 12 times x minus the x piece. Y equals 12x minus 24 plus 6. That should feel very familiar from algebra. Okay. So calculus is able to answer more find the equation of the line questions than algebra was able to, right? So at the moment, that's pretty lame, to be honest, right? You're like, oh, I can do another, oh, yeah. But yes?
Is that the same as y2 minus y1 divided by x2 minus
Yes,
y1?
remember, this, a real quick little lesson. Doesn't matter which points I pick on a line. Will that change the slope? So let me tell you, if I give you a point, couldn't the point you pick be any? So I'm not going to put a little subscript. It doesn't have to be a specific point. It could be any point, correct? And then what do I get if I multiply this up? I get the equation that we use. So that equation does just come from the definition of slope. So if they say, find the equation of the tangent line, this is what you're going to have to do. They're going to give you a function. They're going to give you an input. You go through this limit process. If they say, find the derivative, so derivative is the calculus word for slope. Derivative is just the more general term. So the derivative of a function at a point is the slope of the tangent line to the function at that point. Holy shit. Okay. All right. Some of you look like you want to hurt me. I'll be... Sorry. Some guys are like trying to make a joke. I want to hurt you. Shit. Okay. All right. All right. So let's transition to practice test or homework questions. So that pretty much finishes 2-7. I've got the answer key. I'll give it up to you. Yes.
Can you do 5
2-5. Let's find out. 54. Okay. Yeah. Use the IVT to show that there's a root in the specified interval. So they want me to show that this equation has an answer in here. Now, does the intermediate value theorem say given an equation? And of course, some of you guys are like, we're supposed to memorize that damn theorem? But I want you to at least know this much. What is the intermediate value theorem all about? Given a what kind of what? Given a continuous function. I love it. So on first glance, you're like, IVT says nothing about equations, Jeff. I'm going to write that. It says no, not equations. Is this a trick question? No. They kind of give it away a little bit. There's a root. So how could I rewrite that equation to be a function, finding the root of a function? What does the root of a function mean? The root of all evil. No. Yes, it's where the output is 0. So I really want you to realize this. The way they've given me this problem, the function is hidden. The function that I'm dealing with is hidden. All I have to do to figure it out is to move one side to the other side. Then I have function equals 0. Yes? Then I know what function I'm dealing with. So which way do you want to move stuff? What are you? Oh, good. So there's two functions up there. You guys agree? Okay. So how do I make there be one function? Well, I move everything to one side. So I'm going to move the natural log over. Why not? Now this is my function. Is that a continuous function on that interval? Is this continuous?
Yeah.
This is only discontinuous for values below the 0, right? And this is only discontinuous for values 0 or below. And what values am I using? So is this function that's composed of 3 separate functions, is it continuous? Yes, because each piece is continuous on the interval we're looking at. I like it. So we can say that. F of x, continuous on, what was it, 2, 3. Oh yeah, you got the book in front of your face, Jeff. Since x, square root of x, and ln of x are continuous on 2, 3. Sweet. Let's zoom out a little bit. So then the intermediate value theorem will work. So the beautiful thing is, if I want to show that there's a root, if there's a function that I'm working with, and it's up here over here, how do I show there's a root at some value? I just have to show that it's down here, over here, right? If it was up here, and if it was down there, and if it's continuous, what must happen in the middle? It has to go through the x-axis, correct? So what I would do if I was you is, let me see, what is my interval? 2, 3. So what is f of 2? Plug in the old calculator, see what f of 2 is. Right? If it's negative or positive, you hope that f of 3 is the opposite. So intermediate value theorem in terms of finding roots, or showing there's a root, kicks so much ass. If it's negative on one side and positive on the other side, there's obviously at least one root. Now, it could have infinite roots if it just goes like crazy, but it has at least one place. Does that make sense? That's the most immediate, powerful use of the intermediate value theorem. So I don't know if anybody's trying it out, but we'll find it. Is that all right? Who asked that question? Is that good? You did? Okay. So you're agreeing with me, so you look like you got it. Yes?
So there is no calculator like symbol next to 54, but so to find out we need a calculator or
Yes, yeah, dear God, yeah.
like we won't get
So when they put a little calculator symbol, that means you can use the graphing utilities. You're going to use your calculator in more places, hopefully, dear God. This is not Math 88, and I don't want you to show me 118 times 7. No, right? So, I mean, I'm sorry, you got a good question. The little calculator symbol normally means I can use the graphing utility. For any other problem, you can certainly use, if you got to use square root of 2, don't. Or like natural under 2, don't.
Yeah, that's the thing. I was trying to show it work for like ln of 2, and I'm like, how do I do that?
I got you. So I'm sorry. I was a little bit draconian. The calculator symbol means you can use your graphing utility, but you can use your calculator computation stuff any damn time you need to. Yeah. Okay. Is that okay with everybody? It's a really simple idea about if it positive on one side, negative, it's got to be 0 somewhere in the middle because it's continuous. Now, if the function was not continuous, it could just teleport, and then it doesn't have any x-intercepts, and the intermediate value theorem says it could do whatever the hell it wants to if it's not continuous. Okay. Anything else? Anything from the practice test? Did anybody have time to try that out? Or homework stuff? Anything else? Yes?
I have a question on the practice test.
Yes. I have one left. Let's see.
Are calculators allowed on the exam?
Say again?
Are calculators allowed on the exam?
Yes. Yes. But again, just like the book, you can use the computational powers of a calculator anywhere you want to, but you can't use the graphing utility unless I specifically say, graph it and tell me something from the graph. Yeah.
I was wondering about number 3C. Does how you solve algebraically change when it's coming from the left to the right?
So let me I really want you to understand in general. So for example, if I just said the limit as x goes to 2 of this, can somebody tell me anything about that? As I approach 2 from the right, what sign does the bottom have? So it's positive. Is that cool? If I put numbers bigger than 2 in here, isn't it positive? So what is it going to as I approach it 2 from the right? You think about from your perspective. It's going to positive infinity. Is that all right? It's always 1 divided by a very small positive number that's going to go to a very big positive number. What if it was coming to 2 from the left? Negative. So it's one of these deals. So what's this limit? No. Right? From one side it's going to positive infinity, from the other side it's going to negative infinity. So what is the limit? Does not exist. I can't even be more specific because it doesn't even agree how it freaks out. Right? If it went to positive infinity on both sides, it agrees on how it freaks out. The answer would be positive infinity. But this one can't even agree on how it's freaking out.
So we would know if we plug it in and we get like an answer like undefined, then we would know to check from both sides.
All right, good, beautiful. The very first thing you do for any of these is, do I really have any work to do? Let me just plug the number in and see if there's an issue. Now, when you plug 0 in, there's an obvious problem, right? But what's the problem, though? Is it indeterminate? No, it's negative 2 over 0 in parentheses, right? But why can't you just say negative infinity and be done with it? Because you don't know what sign the bottom is. I really want this to make sense. When I plug a 0 in, isn't this of the form negative 2 over 0?
Yeah.
Why can't I just say that the limit is negative infinity? Because I don't know how the bottom is approaching 0. Maybe it's always negative. In which case it would be positive infinity is the answer. Right? Maybe. Why was this other problem we did so much easier? Because the bottom is stupid simple. This one, not so much. So what's one thing you can do to simplify this? Factor, yes. Factor that thing. If you factor it, it will immediately look much more like that. Okay, I like it. Let me show you something. Do you guys look forward to factoring this? I really want this to make all the sense in the world. Let me write it down again. I'm going to take an h out of the bottom. Is that cool? That's the factoring we should all be like, I got this. In order for factoring this to lead me anywhere, what must be a piece of this? 3h minus 2. Do you guys with me? In order for factoring to do shit for me, 3h minus 2. So it's easy as shit now. It's easy as shit. I really want you guys to agree with me. So what do I know? I know there must be a 3h minus 2. Therefore, what must go here? 4h. And what must go here? Plus 3. And now let's check. 9h minus 8h is h. Am I saying that will always work? Of course not, because it might not have been factorable, in which case we're sort of screwed. But now I can do this, and what do I have left now? 1 over h times 4h plus 3. It was the limit as h goes to 0 from the right? And now I can investigate that, the signs, much easier. Does that make any sense? Okay. But that's so awesome when you have a very constricted problem. The only way factoring would help is if this was a part of it. Let me just assume that's a part of it. Then it's not even factoring anymore. It's just figuring out the numbers to multiply correctly, right? Okay, maybe?
Yeah.
I'd be surprised if you guys never saw that. Because that kind of problem happens in algebra all the damn time. Remember simplifying rational functions? You had to factor the top and bottom. And I was always telling my students, use what you get in one to be a hint for the other one. Anyway, sorry. Okay.
So after you do that, then
Yeah, now, as h goes to 0 from above, isn't this always positive by definition? And if as h goes to 0 from above, isn't this also positive? So then the answer is going to be what kind of infinity? Positive infinity. And I highly recommend putting a plus sign just in case there's like everybody always does an erase and it looks like there's a negative and you're like, I didn't mean negative. So put an actual plus sign there just to really make it clear to me. Okay. I highly recommend it. What time we got? Oh, we got time. Yes.
Can we do, I know that you said that it's going to be an extra credit question, but can we do 7?
I did 7 on the answer key. So oh, did I give you I think yours had writing on the back, right? No? What did I do with the one? Oh, well. So last time I said this is going to be extra credit. This is from section 2.8. And this is from section 2.8. Now, to be really, really honest, you could do number 9 using 2.7 stuff, right? So there will be questions like the ones we just did a minute ago, figuring out the slope of a function at a point and then getting the equation of the tangent line. Are you guys with me? So I could give you number 9, but more specific. I would give you a equals -2. You could set it up. You could figure out the slope and go from there. Okay, maybe. But the way I've worded this number 8 is actually from section 2.8. All section 2.8 does is, right now, you can find the slope of a function at a point. In section 2.8, we're going to find the slope of a function everywhere at once. What's true about the slope of this function? Is it staying the same? No. So what do you think the answer to the slope of this function everywhere will be? It will be its own function, because isn't the slope changing everywhere? Isn't that the definition of a function? So 2,8 takes the idea from we can only look at one point and get the slope to we can get the slope for the whole damn thing anywhere. And all it means is instead of putting a number in for a, we just put x for a. That's what 2,8 does, but there's a little more to it, so I didn't want to throw that in too. All right. So that's going to be on the answer key. Yes?
Can you go over space theorem again real quick?
Yeah.
Page number 5.
Oh, is there one on here? Oh, yeah. Okay. Which piece of this, and it's going to be very obvious normally, which piece of this is already bounded? Which part of that function is already bounded? What does bounded mean?
Stop.
All right, I love you guys. Let me say this. If a function had an upper bound, what does that mean? It doesn't go above that. If the function had a lower bound, it doesn't go below that. If a function is bounded, it's got a ceiling and a floor.
So that's like
The same.
range?
So sorry?
That's like the range?
Yeah, I'm considering the range. So sine, what ceiling and floor does it have? 1 and -1. Okay, let me stop for a minute. So I like the idea of ceiling and floor. That's very, you can see that, right? Sine goes, and then it goes, shit. You can never kind of get away. So look what I can write. I can write this piece definitely lives between. Look at the input of this sign. Look at that input. Is that nice? Does that input look nice? No. Why do we not give a shit? Because no matter what you plug into sine, the lowest you can get out is -1, and the highest you can get out is 1. I really want that to make sense. So the fact that this is disgusting doesn't mean shit to the outputs. The outputs are like, you can be as gross as you want. You can't make me go above 1, and you can't make me go below -1. Now is where we bring in this piece, because I can't say anything. This isn't my function. This is just a piece of it. So now I'm going to multiply everything by this. Now I've built my function in the middle, correct? Did you give yourself enough room? Probably not, Jeff. Jiminy Jeebus. Woohoo! So all I did, very first thing, what is already naturally bounded? Because squeeze theorem is all about something between two things. So if there's any sine or cosine, that's what you write. Bam, bam. Now you say, oh shit, this isn't what they want me to investigate. Let me multiply by the other shit. Bam, bam, bam. So multiply the whole thing by this.
Why did you choose to do sine first?
Because sine was the only one I could write an inequality for. So it feels, again, since we're applying a theorem, it kind of feels like we're cheating. Because some of you guys might say, no, this is, why can't I just take a piece of it? Because I'm going to build it on the next step. Now I'm talking about, well, I left my cube out. Now I'm talking about what they want, right? Poor little cube. Now what's the limit? Now you just bring the limit in. What's the limit as x goes to pi of this? 0, right? As x goes to pi, this is 0, correct? If x gets really close to pi, this is 0. 0. Therefore, this limit has to be 0. I like it. So how do you show that? Well, your next step, limit as x goes to pi of this, limit as x goes to pi of this, limit x goes to pi of this. Can you write that on your paper? I'm fine with that. Right, it's kind of repetitive, right? This is fine. I could take that from you. And this is 0. Sine of shit less than or equal to 0. So then your last statement would be, therefore, I really want this to make sense, right? This side goes to 0. This side goes to 0. Then your last line would say, therefore, this limit equals 0. It was squeezed. Right? The function that it's above and the function that it's always below both went to 0. So it's in here going, help, help, shit. Right?
So do
Do
we have to write all those limits over again? Or would we just be able to write
Yeah, if
0
you
and
wrote
0?
exactly what I wrote, and then your last thing, I'm going to have to use a little bit of scratch paper here. Your last thing would be, therefore, the limit as x goes to pi of x minus pi cubed, sine of 3 over x minus pi equals 0. I like it. I like it. Yes?
Where'd you get pi over in the second?
Pi over 3. Oh, I have no idea.
I was like, where did you?
I'm sorry.
Okay.
That's me writing as I'm thinking about the next step.
So it's supposed to be x minus pi cubed.
Yes.
Okay.
Let me go ahead and give you guys this. Maybe this will. Here's the practice test answer. Oh, by the way, that's right. Let's do number 6 because it got cut off of here. Poor little dude. Did we do number 6? Sure. So you guys see how number 6 is missing? Poor little dude. What was number 6? Oh yeah. Does anyone feel, if you see this problem, does anyone feel like, oh, okay, good? Anybody? No? Okay. I was hoping. Let this problem be simple. Look at the functions themselves. The parts of f of x. Are the parts themselves continuous? Why? You don't have to get any aren't they functions we know are? Isn't this a trig? So you'd say trig is continuous on its domain. And this is just, what kind of function is this? A line, so it's a polynomial.
So it's continuous.
Continuous, right? So those are two of the many kind of functions we know are continuous on their domain, correct? So those pieces are continuous. Where's the only place that might screw this thing up? Pi over 3. Maybe that's where the pi over 3 came from. No. What needs to happen at pi over 3 to make this whole thing continuous? Because the pieces are good. What's got to be happening with the pieces? They have to get to the same thing, right? Okay, I think that's what you said. So all I have to do is do what? All I have to do is plug it in. See what the output is? Now, technically, am I allowed to plug this in to get something? No, but I'm going to plug it in to see where the open hole would be. And then I'm going to plug this in to see if that fills it in.
What are you plugging in?
Say again?
What are you plugging in?
What's the only place where this whole function could collapse, could not be continuous? Is here. If this goes here and this goes here, it's not continuous. They have to have the same value at pi over 3. I really want that. So,
Is it saying is it saying 2 cosine 3x when x is
yes, that's how, yes, piecewise functions tell you this function is this when this. This function is this when this. So I want to know what the part is, and I want to know when that part takes control. At pi over 3, this dude takes over. that dude better take over at the same place, or this is weird, right? If I'm running a relay race with the batons, and I'm coming in, and the person's waiting for me up there, are we going to do good? We're going to suck. They're like, what the shit are you doing? Right? We throw it at you. No, okay. No? Do I use too many analogies? Yes?
Go over like how you would write this, or like explaining why it would be continuous everywhere.
Yes, what did I? Oh, that's right. I forgot. I was like, what did I put in the answer key? Well, that's why I'm looking, because I didn't do it. So you would say trig functions continuous on their domain. And you could put polynomials. Yeah. Trig functions and polynomials continuous on their domain. So the parts have no problem. At pi over 3, let's see, if you want to be really technical about this, I would kind of allow for a little less technical. So I would say 2 cosine of 3 times pi over 3. What is that? At pi over 3, what does this want to be? Negative 2. And at pi over 3, what does this want to be? Negative 2. Therefore, this is continuous because those agree. Now, if you want to be more technical, you could talk about limits. The limit of the function as it approaches pi over 3 from below is this. The limit of the function as it approaches pi over 3 from the right, let me say it like that, is this. Therefore, it's continuous.
But we don't need to do that, do we?
No, I would take this. This is fine. Yeah. Because that's the only point he could mess up. And as long as he starts from the same place, it's golden. If they don't do that, it's obviously a jump discontinuity. I like it. I would not do this, but why would this be easy? All right, let me give you something that looks disgusting as shit. What do you got, Jeff? What do you got, Jeff? It doesn't matter, dude. You're going to make this point, so it doesn't matter. Why is that one an easy, quick answer? Is this function continuous? Everywhere. No. Where's it discontinuous? At 2. Now, technically, this is why I wouldn't give it to you. Because as long as a function is continuous on its domain, it's continuous. Does this guy's domain include 2? Is it continuous everywhere except 2? This, of course, yeah, it is, because this is fun. Yeah, that's why you made it that way. All right, I'm sorry. That was a step too far. It's
So
like,
would that be continuous or not?
this would technically be continuous.
Okay.
Because it is continuous on its domain. The only place it wouldn't be is 2, and 2 is not in its domain. That's why I would never give that to you, because it's a little evil. A little more evil than I want to be, right? Give me like 10 years.
Can you make an extra credit question?
Maybe, if I remember. It wouldn't be exactly like that, because I've already talked about that. So, anything else from that practice test? Did I get my answer key right? You guys want to double check that? I'm averaging about a 97 on my answer keys, so I feel pretty good. I just want to remind you guys, I am human. If you think I made a mistake, there is a chance I did. Right? I'm just a human being. Sorry, it gets a little bunched up in there. I should have done it on another sheet of paper, the whole thing. But, oh. Yes.
I think we already went over this, but where you get the negative one column
It's not from the squeeze theorem. It's just the fact. Where'd that go? Where did I put you? There it is. Oh, well, no. Where did I put you? Here. There we go. Okay. What is true about sine? Always. No matter where the hell you see it, what's always true about sine of something? Isn't it always between? Yeah. So that is just a true statement. Right? seems a little disconnected from the problem in a sense because that's not the function they're asking for, but then the very next step, I create the function they want. But now I know the function they want is bounded between these two functions. And that's where squeeze theorem is like, I got you. As long as the ceiling and the floor come together, function in the middle is dead. It's got to agree with them because it's got no other choice. I can't stop thinking about that trash compactor scene from Star Wars. Squeeze theorem. Luke, your misunderstanding of calculus is gross. All these are for me. There, I like that. Yes. Yeah. I love when you're done with your little thing, Jeff.
I just didn't want to interrupt before we started to so. So we talked about this in class, and I was like, so as long as the limit is continuous, and they both agree on both sides, what that means.
Now be really careful how you say that. As long as, so what does it take to be continuous at a point? The limits have to agree. So don't say limits are continuous. That doesn't make sense.
Oh, sorry.
Okay.
Yeah.
So to be continuous, the limits have to agree, and the function value has to actually be that limit. I think I have it written up here. So what does this mean? If I write this equals a number, that means the limit from one side and the limit from the other side agree. And they are what the function is there. It fills that hole in. Yes?
Yes.
Okay.
So then this would be.
So, but see here, you're sort of assuming it's continuous to explain why it's continuous.
As long as the limit's defined there and they both agree.
Yes.
Does that mean it's continuous?
Yes. So here it says, because they approach the same value. Oh, you never said the function has that value. You see what I mean? You focused only on this. You never said that the function value agrees with that limit. Does that make sense? You never made that connection. You only talked about the limit. The limit's defined because they approach, the limit approaches the same value.
Yeah.
But you never said that value is the function value. That's the connection. Because they could approach the same value, but the function could be somewhere else, right? A little dot somewhere else.
Right.
So
But it's.
I really want that to make sense.
No,
you
I do.
never told me that the hole that limit might create is actually filled in. But you have to say it, right? So that's the whole thing is, I'm trying to make sure you understand all the parts of this. So you have to say this, and you have to say this.
Well, that about half the problem, right? Half the difference.
That's what you got.
Oh, this is 12. This is 12 points.
Yes.
Oh.
I love you guys. How many problems were on this quiz?
Technically 2, but they're all.
Yeah, exactly. So I think, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they're all worth like 9 or 10 points or something? Yeah.
Almost being what's.
Yes.
On the test, are you gonna highlight what is and isn't a bonus problem?
Oh, totally. Yeah, the bonus, it'll say bonus section. And they normally give you 1 or 2 or 3 bonus questions. So it'll say bonus section, and then there'll be some problems after that.
I
Yeah.
know here you're like, oh, by the way, this is a bonus.
Oh, because I originally made that thinking I would get through 2A,
Okay.
right? And then the epsilon delta thing, I decided to go ahead and make that bonus. Yeah.
I was wondering if you could do maybe
Which one?
2.5, 30.
2.5, 30. Cool. So they got theorems 4, 5, 7, and 9. Why the function is continuous at every number in its domain. So you got this guy. So those are all about which functions are continuous, what's true about f over g. So if you look at those theorems, let's see, where are you? Theorem 5. Here's theorem 4. Theorem 4 is the one about f over, oh shit. f over g, right? That's the one that kind of applies for us. And also, does it have a, no. Okay. So I've got a function on top, I got a function at the bottom, so as long as the bottom's not 0 somewhere, right? Then I've got theorem 5 is about rational functions and polynomial functions. 7 is the complete list of all the functions that are continuous in places, right? So what is this function composed of? It's composed of a trig. Trig functions are continuous on the domain. It's composed of a root function. Root function's continuous on the domain. And then it's got a function divided by another function, and that's continuous everywhere on its domain where g is not 0. Yeah.
So it's still so we just have to explain.
Yeah, point to the theorem, say the division is continuous because it's a division of two continuous things. This one's continuous because it's trig. This one's continuous because
So number 6, that we did on the practice test, right?
Oh, no. Number 6 is a very specific application of continuity. That is a more general, it's not talking about a specific point. It's just saying, why is this a continuous function? So it's because it's made of functions that are continuous, and its division is still continuous. Yeah.
For those questions, it also says to use theorem 9. And I didn't know how to use that.
Oh, if you need to, I think. I don't think every single one of these are supposed to be all 4 used. Yeah. They meant to use them as you need to. Yeah. So, I mean, you could use it on the bottom. Root functions are continuous. Polynomial functions are continuous. It's a composition.
Oh.
Yeah. And of course, you can talk about the roots on its domain because not everything works.
But we wouldn't need to.
No, because
Because
the
it's
theorem
continuous.
involves it's continuous on its domain. And I think, yeah. Continuous every number in its domain. And then, of course, the state the domain piece is what I think might be more interesting, especially for this problem. That I think would be the hard part.
So you gotta know your
No, I'm not going to make you tell me which theorem 5 is something. No, you do have to have a feel for what the polynomials and rational and root functions, all those are continuous. You have to have a feel for that, right? And then you have to know if I add two continuous functions or if I multiply, then that's still continuous, right? So it's just a general understanding. You don't have to be able to recite to meet each theorem. Yeah.
Can I get my quiz back?
Oh yeah. Anybody else come in not get their quiz back yet? George?
Yeah.
Hey, Mark. Here. All right, so you guys can make corrections on those. When are corrections on quizzes due? Test day, so Wednesday. Oh, by the way, screw it. The last 2 days I've been workshops and classes. I didn't grade shit you gave me on Wednesday. So if you want to pick up your graded work, I'm going to grade your homework over the weekend. I am going to send an email out with specific information about my office hours because now I'm coming to each classroom and I'm going to finally add some Zoom office hours. So you could come to my office hours on Tuesday to pick up your homework if you want to. So you can have it to look over. I'm sorry, I skipped over somebody.
I have a question on the practice part.
Yeah.
For 7, I got to the absolute value of negative 3x minus 6 is less than E1, sorry.
Here's my blank. Here it is. Number 7.
Yeah, and then I checked the E. How am I getting that 8 in that minus 8?
Sorry, where are we at? Oh, here?
Yeah.
Because negative 6 is 8 minus 14.
That'll do it.
And of course, I mean, there's no way you could just sort of if just rewrite negative 6 correctly now. No. So where did I really get it from? This step. Remember the side work? I just kind of do it backwards. There's no way you can mystically, magically know in general how to rewrite negative 6. Yeah. So that side work does a lot of heavy lifting. Yes. Oh, I'm sorry. Did you have
Oh, yeah, so for, obviously I was done my SQL and it's not doing this. I did my test.
Oh, yeah.
It's totally done. But what kind of discontinuity is it? Cause it's not a jump, it's not a removable. this
Why?
is not-
No. So I don't know why everybody thinks. If there's a pothole, is that removable? Yes. Like fill it in. It doesn't matter if somebody tried to and accidentally filled something else in if they missed it.
Okay.
So it doesn't have to have a place. If there's a pothole, it's removable. If the road is good, but there's a pothole, I could remove it. If the road's not good like this, it's obviously junk, no matter what the hell's going on. Yeah.
Like this, I don't know if they found
This here?
yeah.
Oh, okay. There's a little thing that we sort of skipped over a bit. We didn't really skip it over, but I didn't really make a big deal out of it. When am I truly allowed to plug a limit number in? What's got to be true about the functions? Why can I just plug a pi in? Because these functions are continuous. So that is when I'm actually officially allowed to throw a limit number in, is if I'm dealing with continuous functions.
Okay, so that's all I would do for that.
Yeah. So use continuities since the sign is continuous and the composition of two signs are continuous, right? And of course that's continuous. I'm allowed to throw a pi in. Yep.
So you have to check the continuity before you.
Yes, technically. I know that we've sort of been doing it a little loosely, but that's because we've been dealing with really nice functions. So they're continuous, so we can just throw it in. Technically, you're only allowed to throw the limit number in if the functions you're dealing with are continuous at that point. And of course, sine function is continuous everywhere. X is continuous everywhere. Composition functions are continuous on their domain. Yes?
I had a question for 1G on this. I thought that it was continuous because there's a point here and a point here, and so the continuous theory that we
Oh.
talked about, it has to pass through an X.
Yeah.
That doesn't explain what is the function itself. You don't know. Yes? So you're sort of saying, I went right through it. But that's not using the definition of continuity. The definition of continuity is the limits agree and the function value agrees with that limit.
Oh,
So I needed to see exactly that.
okay.
You're doing it less technically, but I specifically said use the definition of continuity.
Okay.
Yep. So this is 2.2 number 33. Whoa, holy shit. So determine the infinite limit. As x goes to 1. What do you get on the top? 1. So it's all about the sign of the bottom, because the bottom is going to 0. So the answer is going to be some kind of infinity, or maybe does not exist if it doesn't agree. But what is the bottom always, no matter if it's below or above 1? No, if I plug a number a little bit above 1, it's squared. So, I mean, I don't even have to think of that much about it. It's always positive, so the answer's got to be positive infinity, right? Because the top is finite and the bottom is infinite. It's just fun to say it that way. Infinite. Yes.
Which question? I remember we talked about the clarity. How you above and below it, just,
Oh, the table.
12.
Does it say use the table? No, it just says use the definition.
Because I kind of, I wanted to do the outcome.
So the definition of continuity, you have to show that the limit from below and the limit from above are the same. So the definition of continuity is all about the limits agree and the function value equal. equals that.
So how would I show it?
It's almost hard because it's such a simple thing, right? Because you can plug a 2 in, and there's no problem, right? So use the definition of continuity. So you would technically just have to write the limit as t goes to 2. From below, negative is, plug it in. The limit as t goes to 2 from above is, yeah. It's a little bit, it's just getting you used to the parts of the definition of continuity. Yeah.
Page 114. What is that weird looking 8?
114 number what?
19 through 32. What is the weird looking 8?
Weird looking 8. Oh!
Oh, is that a delta?
This is what delta looks like in the font they use.
Okay.
It's what epsilon looks like. It's what delta looks like. Yeah, so their delta kind of like got smushed. Yes.
I put indeterminate here.
Oh, yeah, indeterminate doesn't mean that what you think. It just means it's 0 over 0 or something.
Okay.
So that should be does not exist.
Okay.
Yeah.
I figured it was one of two things. I put -1.
No, that one's
Oh. Yeah, I did. Yeah, where did you put it?
No, I didn't. I didn't put split, so I did.
Exactly. The problem is that's the part that makes it not able to handle 3. Once you kill it,
Yeah, then you just plug in 3 and then you get a maximum 6.
oh, that's right. There was this handout I gave out last time that I completely forgot about. But semi-quickly, can somebody tell me what that symbol means? Derivative. Now, say less calculus-y. Say, all right, tell me the idea. Yeah, I think I just heard it. Slope of the function at -2. Okay, cool. So what I want you to do is which one of these slopes is most negative or smallest, right? So what is it at -2? It looks to be positive, correct? Right? The positive slope. But at let's see, at 3, what's true about that slope? Which one's bigger? At -2 or at 3? 3 is obviously a steeper slope, yes? So far I know that's bigger than that. Right? And then you kind of keep going. Okay? So that's not that bad. As long as you know what that symbol means, it just means slope. You look at each point and you think about the tangent line. How big is the tangent line slope? Okay? This one is something left over from algebra. When you figure out slopes, aren't they rates? Rates of change? So if my x's were time in hours and my y's were miles driven, what units would my slope have? This is hours, this is miles. My slope would have what units? Y's over x's. Miles over, oh gosh, what's happening out there? Okay. If I have miles, hours. Yeah. What units does my slope have? Yeah, miles per hour because it's y's over x's. So the whole thing about whatever this units on y and x are, it's the ratio of those units for the slope. So here, what are the units of p prime? Well, you got to know what p is the output, and you have to know what A is, the input. So what does P represent? Profit in thousands of dollars. So we got thousands of dollars per, but what does A represent? So this is thousands of dollars profit per thousands of dollars ad expenditures, right? So it's basically profit per ad expenditures and thousands of dollars. So that's all you do for slope, is whatever the outputs units are, whatever the inputs units are, the slope is a ratio of those, just like miles per hour. I like it. What if P prime was positive? What does that mean? Let me see. If my if I had hours and miles, and my derivative was positive, what does that mean? Am I getting closer or further away?
Further away.
Yeah, I'm going away, right? So if my slope is positive, I'm racking up more of this for every one of those, right? For every little motion on this, I'm going to rack up more of those. If it's negative, that means I'm starting coming back home. So what does it mean if that's positive? That means that my profit would be increasing for every extra money I put into ads, right? P prime is profit increase basically, so that would mean my profit's increasing. If I paid for more ads, my profit would increase. That's what that means. So I don't know if you guys know, there's a position at companies called financial analyst, and they make stupid money because their job is to calculate functions, figure out derivatives, what's the price point, what's the demand right now. They're always trying to figure out, should I spend more on ads or less? Should I spend more on this or that, you know? And they're trying to figure out future, does it look like we would go up with more, or does it look like we should pull back? Where am I on that profit curve, right? And I'm not really a business dude, so that's about all I know. Okay. What the hell does this mean? What does the input mean? Yeah, advertising. So they spent how much money? 500,000 spent on ads. And this is a P prime, right? So when I've spent $500,000 on ads, my profit would go up by $2,000 if I spent more on ads. So the slope is $2,000, right? $2,000 increase for every $1,000 I would spend more in ads. So in that case, if that's what the financial analysts saw, they would say spend some more on ads. I think we'll make some more money if we do. Okay. Let me think. Is this more in? I can't remember which one this is more in. Of course, that's basically what I just said. If this is true, should they spend slightly more or slightly less? They should spend slightly more. I don't know why I said 100,000. I think I changed the numbers at some point. All right, anyway. So I'm not going to be too specific about this kind of stuff. But this one we should definitely be able to do. This is all about slopes. So all you have to do is keep your eye on what the slope looks to be at those points. Okay, maybe. And then the units idea, that's from algebra. You always had to figure out what the units were when you did a slope of something. It's just the y units divided by the x units. Okay. Anything else, guys? Yes?
2.734.
Oh. Yeah, so this is the one that sort of starts to lead into the next section. So what is the process? What process do we use? Once I find some paper. Sweet. Where'd it go? Down there. So x to the negative 2. So let me write this stuff down. So we got given f of x equals x to the negative 2. I want to find the slope at a. This kind of sucks because they didn't give us a value for a, right? But what's the idea? The limit as x, get out of there, as h goes to 0, f of a plus h minus f of a over h. Is that cool? And I don't put a number in here now. I just keep it as a. So this is really what 2.8 is going to be all about. So this homework problem was to get you ready for 2.8 when I don't put a particular number in. So let's see what this looks like. What is f of a plus h? Let's build each part I need. I need this part. What is f of a plus h? Let's write this better. Isn't this just 1 over x squared? So what is f of a plus h? 1 over a plus h squared. And what is f of a? 1 over a squared. All right. I'm not going to multiply them out yet. I'm going to see if we need to. So let me throw everything I know in here. I know f of a plus h. I know f of a. So then you're faced with that thing. Okay. So what the shit? How do I go from here?
Combine the two fractions.
Combine the fractions. I love it. So when you're not sure and you got these fractional parts, go ahead and try to throw them together and hope to God something good happens. So this is pretty simple, yes? Isn't this guy missing him and this guy's missing him and so then I just give them each. See, are you guys able to do this here? I'm just going to multiply this by a squared, top and bottom. I'm going to keep this over h down here. And then I'm going to multiply this one by a plus h squared, top and bottom. You guys okay with me? You guys okay out there? So multiply him by a squared over this a squared. Multiply him by a plus h squared, top and bottom, a plus h squared over this. And then I can put them together. Does that look any better? A little bit, because now, can't I simplify the top here? Can I simplify the top? Of course I can. That's pretty nice, right? No? You guys okay out there? So this will be a squared. I can kind of, anytime you want to, you can pull a piece aside just to focus on it. Minus, no, Jeff. There we go. Die. Right, so now these will die. The negative goes through. I don't know how you guys feel. Now here's the trick. Here's the thing that makes me a little sad. So on the top, so let me rewrite what we got. We got the top now. Is everybody cool with this? These die and then the negative comes through? Yes? Does anyone know how to rewrite all that? There's like a fraction inside of a fraction, correct? You guys know how to rewrite that?
Oh, flip the h back.
I could just put that there. Yes? Because I got the whole thing divided by h. Isn't that times 1 over h? So doesn't the h just sort of go there? So I can put this. That's the part that kills me. So that's sort of like, what is 1/2 divided by 3? 1/6. I can just put the 3 up with the 2, right? Because 1/2 divided by 3 is 1/2 times 1/3. 2 and 3 go together. No worries. That happens often enough that you need to be able to do it kind of quickly. And you're basically done. I mean, what do you do next? Why can't I plug a 0 in for h? Because the top and bottom becomes 0, correct? It's because if that wasn't there, wouldn't the bottom not be 0? Can't I kill it? Yes, good. All right, so then you can finish that out. Is that cool? Okay. All right, I think that's it. I got a department meeting at 10:30, so I need to head out. I love you guys. This is awesome. My other class are like looking at the clock.
I'm sorry, really quick. Can you fix this? When I press my Y,